So 5.5 is all about bases other than e. So we're talking about something like 3 to the x instead of e to the x and taking the derivative of that. And you can't just do like a power rule on them, which is unfortunate, but just does not work. So I'm going to show you how to kind of come up with some of these. And so the very first one, what I'm going to do, and it's not the only way I don't think to do this, is I'm going to write it as y equals a to the x. And the way to get the kind of the a out of there is I'm going to take the natural log of both sides. So natural log of y equals natural log of a to the x. So I'm using my rules of powers, I can take the x out front. Now we're talking about natural logs base e. So we can take the derivative of both sides. Now we're taking the derivative in terms of x because that's what we're trying to do. So we're going to have the derivative of y is going to be y prime over the original is going to be y. So when you use this to take a complicated derivative, taking the natural log of both sides, we're going to do the exact same thing. Now on the right, you might think product rule, but a is a constant. You're not going to have x to the x. This is going to be like 5 to the x, 7 to the x, 3 to the x. So natural log of a is a constant. So x times a constant is just the constant. This is x to the first, goes away. X to the 0 is just 1. So from here, all we have to do to find y prime is we multiply both sides by y. So y prime equals, well, what's y? A to the x ln of a. Okay? If you think about this in terms of e's, so if y equals e to the x, and we want to use this fun formula here, and this is a, it's e to the x ln of e. Well, ln of e is 1, so it's just e to the x. So the rule here, which is the rule that we're trying to get across, is the exact same thing. All right, next one is even easier. So if you want to do log base a of x, we're going to use change of base formula. So we do ln of x divided by ln of a. Now again, you might want to do quotient rule, and we don't have to do the ln of y. I'm just using change of base. So y prime, again, this is divided by a constant, so quotient rule does not need to be used. If you use quotient rule, that's cool. The derivative of this is going to be 0. Parts of it are going to drop out. But however, the derivative of the natural log of x is, well, derivative of x, which is 1 over x. And then you have a natural log of a in the denominator. Oh. So that is the derivative of log base a of a. So here, let's write this way. So dx, which I didn't give myself that much room, a to the x is a to the x ln of a, dx of log base a of x equals 1 over x ln of a. And if you think about it, if I have y equals ln of x, this is the same thing as saying y equals log base e of x. So if I use my formula, it's 1 over x ln of e. ln of e is again 1. So derivative of natural log of x is just 1 over x. And don't forget, we still have to put the dx on top. So if this was a u, this would be a u, and this would be a du. So that's more along the lines of what the front of the book is going to have. So don't forget your chain rule. That is always true. Now let's think about this. ln of a is a constant, so this is not so much of a proof, just more common sense. So if you're doing the derivative, you have to multiply by a natural log of a. But the a to the x stays the same. So if you're doing the antiderivative, the exact opposite, it's going to stay the same, and you're not going to multiply by natural log of a. You're going to divide by natural log of a. And then don't forget a plus c. So that's not really a proof. It's more along the lines of common sense based on the derivative. All right, let's see if we can't use some of it. All right, so our a is 2, so we want to think of this as a to the x. So the derivative is a to the x, or 2 to the x, times natural log of the a. So ln of 2. That's it. Now, some people are just going to choose to do ln of cosine of x divided by ln of 10 and work with it that way, but it ends up being over cosine of x, but it's not really 1 over cosine of x, it's the derivative. We have to put that du on the top. It's du over u. That's always how we do anytime we're doing a log or a natural log. Okay, so if this was a natural log, it would be the derivative, which would be negative sine of x, And then the other thing is we have to put it over ln of a, which is 10. So if we do it this way, change the base, you have exactly the same thing. You have the natural log of 10 in the bottom. Now, you might not see that written that way. It's probably written as negative tangent x divided by ln of 10. That's probably how you would see it. All right, next one here, you got to use product rule. There's two products. You can't just kind of bring it in and make it 6 to the negative x or something weird like that. They're not the same basis, so take the derivative of the first part, leave the second part alone, or vice versa. It doesn't matter which order you do these in. Plus, leave the first part alone, derivative of the second part. 6 to the negative 2x times the derivative of the inside, the negative 2, and then you got to multiply by the ln of 6. And you can do these in either order, but you have to. If you have a 2x, you better be taking the derivative of that at some point. So the normal formula, don't forget there's always that chain rule that has to happen. So whichever one you put in whichever order, it's no big deal. Other thing that the AP exam will probably do is it probably will factor out the 6 to the negative 2x. First off, I'm okay with that answer. I mean, maybe not right in the 1, and maybe you might want to put the 2 out front and with a minus 2, but the AP exam will probably have it this way. 1 minus 2x ln of 6, where they factor out the GCF. And you don't have to do that in my class, but you'll probably see your answers written that way. All right, when we want to do antiderivatives, if you were doing the derivative, it would be 4 to the x times the natural log of 4. However, the antiderivative, you're not going to multiply, you're going to divide by ln of the base, and then put a plus c. If it's more complicated, as far as what we know now, you're probably going to need a u substitution, 3x squared. And then du would be our 6x dx. We have an x dx, but the problem is we do not have the 6. So we've talked about doing this a couple different ways, but the most basic way is solve for dx, which is du over 6x. And then you plug everything you can in. So x I don't know, 2 to the u, but then dx is du over 6x. The x's cancel out, and we can bring this 1/6 out front and then deal with the problem the way it is. So it'll be 1/6, 2 to the u, and then the derivative would be ln of 2, but the antiderivative would be divided by ln of 2 plus c, and then the last thing we have to do is plug in what our u is. And it's not ln squared, it's ln of 2. Alright, I'll let you think about the next one, but again, your u is going to be the sine of x. This really only works nice if it's 5 to the u. 5 to the x, something very easy. If it's 5 to the 2u, then you've got some trickiness you got to deal with. You're going to have to deal with the 2. So you got to deal with the sign. You can't just try to do it as it is.